Hello friends, I welcome you all to this video lecture on engineering mechanics. In this video lecture, we are going to learn a topic known as projectile motion. So let us understand what is projectile motion. When a particle is thrown in any direction other than the vertical direction, it moves along a curved path and the motion is known as projectile motion. If we throw the particle vertically upward, it falls vertically downward. And if we throw in any other direction rather than vertical, it will take a curved path and the motion is known as projectile motion. So let us understand how does a motion takes along a curved path. So let us assume that the ball is thrown with certain initial velocity at certain angle with horizontal, and we resolve this velocity into horizontal and vertical components. So my dear friend, there are two components of the velocity. One is horizontal component of the velocity and another is vertical component of the velocity. And both the velocity will try to take a motion along its direction. So the horizontal velocity is going to cause a horizontal motion and the vertical velocity is going to cause a vertical motion, and because of these two velocities there will be a motion along a curved path. So my dear friend, we can conclude that a projectile motion is a combination of horizontal motion and vertical motion. The horizontal motion tries to move the particle in the forward direction and the vertical motion tries to take the particle upward. But as the particle is under the influence of acceleration due to gravity, the particle will not always go upward. The particle will attain certain height, and after attaining certain height it will not be able to go forward, then it will fall back towards the ground because of acceleration due to gravity. So my dear friend, as it is already discussed that projectile motion is a combination of horizontal motion and vertical motion, we can also say that projectile motion is a combination of horizontal motion and motion under gravity. My dear friend, as the velocity is resolved into horizontal component of the velocity and vertical component of the velocity, the vertical component of the velocity first decreases because of acceleration due to gravity, then it becomes zero at the maximum height, and then the particle moves towards the surface of the ground. Is that clear? Whereas the horizontal component of the velocity remains constant if we ignore the air resistance. So the horizontal velocity is a constant velocity, so we can say that horizontal motion is a uniform velocity motion, whereas the vertical motion is motion under gravity or uniform acceleration motion. So because of acceleration due to gravity, the velocity is first going to reduce and then it becomes zero at maximum height. So it is very clear that horizontal velocity is constant throughout the motion, whereas the vertical velocity decreases because of acceleration due to gravity. It becomes zero at the maximum height, and after attaining a maximum height, now the acceleration due to gravity is going to attract the body towards the surface of the earth. So the particle starts falling down and the velocity is towards the ground surface, and it goes on increasing as it goes down and down. So because of acceleration due to gravity, the particle goes upward and then downward, and because of constant horizontal velocity it moves in the forward direction. So this combination of horizontal and vertical motion moves the particle along a curved path, and the motion is known as projectile motion. So we have to remember that projectile motion is a combination of horizontal motion and vertical motion. Horizontal motion is an example of uniform velocity motion. Vertical motion is an example of motion under gravity. When the particle reaches the maximum height, the vertical component of the velocity becomes zero, and after that the direction of the velocity changes. So initially the vertical motion was causing a upward motion, then it reduces, it becomes zero, now the direction is changed and it goes on increasing as it goes down and down, whereas the horizontal velocity remains constant. So my dear friend, the initial velocity by which the particle was thrown is known as velocity of projection, and the angle by which it was thrown with respect to horizontal is known as angle of projection. The path traced by the particle is known as trajectory, and this trajectory is parabolic in nature, which we are going to derive, and I am going to explain you how it is parabolic in nature. So before we go to the mathematical analysis of this projectile motion, let us understand some important parameters. Number one, trajectory. The path traced by a projectile in the space is known as trajectory. The velocity with which a projectile is projected is known as velocity of projection. The angle with the horizontal at which a projectile is projected is known as angle of projection. And the total time for which the particle remains in air is known as time of flight. And the horizontal distance covered by the particle in projectile motion is known as range. So in this video lecture we are going to first define the parabolic nature of the trajectory, and then we are going to find out the formula for time of flight, range and maximum height attained by the particle. So let's do the analysis of the projectile motion. Let us consider a particle is thrown from point O and it falls at point A. The particle was projected with initial velocity u at an angle of alpha. So the velocity of projection is u and the angle of projection is alpha. Now this particle is projected, it will have two components. One is the horizontal component of the velocity and one will be the vertical component of the velocity. The horizontal component of the velocity is going to remain constant throughout the motion, whereas the vertical component of the velocity is under the influence of acceleration due to gravity. The vertical component of the velocity is under the influence of acceleration due to gravity, and the vertical component of the velocity is going to decrease till it reaches the maximum height, and then again it starts from zero in the downward direction. Is that okay? So the initial horizontal velocity is u cos alpha and it is going to remain constant throughout the motion, whereas the initial vertical velocity is u sin alpha. It becomes zero at the maximum height and then it again starts from zero in the forward direction, in the downward direction. So let us start with the analysis. So let us consider any point P on the path and let x and y be the coordinates of the point P. So the coordinates of point P is x comma y, and as we have already discussed that horizontal component of the velocity of projection is u cos alpha, vertical component is u sin alpha, and as we are discussing about point P, we are going to use a kinematical equation S equals to ut plus half at square. This formula is applicable only for the vertical motion, as vertical motion is motion under gravity and kinematical equations are applicable over there, whereas the horizontal motion is uniform velocity motion and there only one formula is there, v is equals to s by t. So applying s equals to ut plus half at square for vertical motion. So what is the vertical displacement for point P? The y is the vertical displacement for point P. What is the initial velocity for motion O to P? Initial velocity is u sin alpha. Let t be the time taken, and what is the acceleration? Acceleration is minus z, as the particle is going upward and the acceleration due to gravity always acts vertically downward. So substituting s equals to y, u equals to u sin alpha, a equals to minus z, we get the equation as y equals to u sin alpha t minus half gt square. Now substituting this formula, v equals to s by t for the horizontal motion. The horizontal velocity is u cos alpha, time taken is t, and the displacement for motion O to P is x. So we get the formula and we convert it in the form of time. So time becomes x upon u cos alpha. Substituting this t equals to x upon u cos alpha over here, we are going to get y equals to u sin alpha. Substituted t, x equals to u, x upon u cos alpha. Substituted t as x upon u cos alpha, and we got u sin alpha into x upon u cos alpha. Sin alpha divided by cos alpha becomes tan alpha, and we get y equals to x tan alpha minus gx square upon 2u square cos square alpha. So my dear friend, this is the equation for the path of the projectile motion. So as we have derived the equation for the path of the projectile motion, and we come across that y is the function of x square. Here y is function of this x square, that means this path is parabolic in nature. That means we can say that equation of the trajectory is a parabola. Now this is a very important formula, this is a very important relationship, this is a very important equation which will help us to find time of flight, horizontal range and maximum height of a projectile. So let's find one by one. First we are going to find time of flight, then we are going to find horizontal range, and we are going to find maximum height of a projectile. Now my dear friend, if I want to find time of flight, I am going to consider the whole motion, that is motion from point O to motion at point A. So considering the motion from point O to A, it will take the total time. Now I will ask you all one question. If the particle was projected from level O, point O on the ground, and again it falls on the ground at A, what is the vertical displacement? So the vertical displacement is 0. Yes. So substituting y equals to 0 over here, and as soon as I substitute y equals to 0 over here, we get the formula for time. So this goes on the other side and we get t equals to 2u sin alpha upon g. So please note down this formula, t equals to 2u sin alpha upon g is the formula for time of flight of a projectile motion. Next we are supposed to determine the range. Now if we want to determine the range, the formula of range can be found with the help of the formula of uniform velocity motion. The only formula which is there in uniform velocity motion is v is equals to s by t. Now I need range. What is the range? It is the displacement. So if v is equals to s by t, therefore s equals to v into t. So substituting horizontal range, s is equals to velocity into time. As we know that horizontal velocity is constant throughout the motion and it is u cos alpha, and we have just got the formula for time of flight as 2u sin alpha upon g. Substituting u cos alpha as horizontal velocity and time as 2u sin alpha upon g, we get the formula for horizontal range. I multiply cos alpha with sin alpha. The formula for horizontal range comes as u square sin 2 alpha upon g. So this is the formula for range, u square sin 2 alpha upon g. So far we have derived equation of the path of projectile. Second is time of flight, which is 2u sin alpha upon g. Third is range, u square sin 2 alpha upon g. And now the last one is the maximum height. So as we have already discussed that when the particle reaches the maximum height, the final velocity, when the particle reaches the maximum height, the vertical velocity becomes 0. As we have already discussed, when the particle reaches maximum height, the vertical velocity becomes 0. So considering v square is equal to u square plus 2a, so when a particle is projected, it is going to reach certain height. This is the maximum height attained by the particle, and let us say this is point C. At point C, the height is maximum height. Let us say the maximum height is h. As we have already discussed, when the particle attains maximum height, the vertical component of the velocity becomes 0. So the vertical component of the velocity will become 0 when the particle attains maximum height. Is that okay, my dear friend? Now considering motion O to C, and applying kinematical equation, v square is equals to u square plus 2as. So what is the final velocity? Final velocity is 0. Final velocity is 0 at point C. And what is the initial velocity? Initial velocity is u sin alpha. What is the acceleration? Acceleration is minus g. And what is s? S is the height attained. So substituting 0 over here, substituting u sin alpha over here, substituting minus g over here, we get the beautiful formula of maximum height attained by the particle, which is u square sin square alpha upon 2g. So by this we have studied the projectile motion, we have studied the nature of the projectile path, we have got the equation of the path of the projectile, we determined the formula for time of flight, we determined the formula for maximum range, and we have determined a formula for maximum height, and you all are supposed to remember that this formula is applicable only for a horizontal plane. That means if the particle is thrown and the particle fall at the same plane. Is that okay, my dear friend? So after completing the analysis of projectile motion, we are going to understand this topic with the help of some numericals. So let's understand the first numerical. An aircraft is moving horizontally at 108 km per hour at an altitude of 1000 meter towards a target on the ground. It releases a bomb which hits the target. Estimate the horizontal distance of the aircraft from the target when it released the bomb. Also calculate the direction and velocity with which the bomb hits the target. Ignore the air friction. So let's draw the graphical approach to understand this. So the particle is thrown from point A over here. The particle hits the target at point B over here. So the particle is traveling a horizontal distance which we are going to say as range. As we already know the formula of range. So this formula of range which we have decided is applicable only for the same plane. So we are not going to use any formula for time of flight, range and maximum height. Is that okay, my dear friend? So here we are going to do the simultaneous horizontal and vertical analysis. As we already know that what projectile motion is a combination of As we already know that projectile motion is a combination of horizontal motion and vertical motion. The horizontal component of the velocity remains constant and the vertical component of the velocity is under the influence of acceleration due to gravity. So, we are going to do simultaneous treatment of horizontal and vertical motion. Is that okay, my dear friends? Since the particle was traveling initially with velocity 108 km per hour and it was horizontal in nature, so we have initial horizontal velocity. If the target was thrown horizontally, so there is no vertical velocity. So for the vertical motion, the initial velocity is 0 and for the horizontal motion it is 108 kmph, which when converted it becomes 30 meter per second. We have multiplied 108 by 5 by 18 and we got 30 meter per second. As we are supposed to remember that vertical motion is an example of motion under gravity which is under the constant acceleration of 9.81 meter per second square. Is that okay? Let t is the time required by the bomb to hit the target, and the vertical displacement, the vertical height was given as 1000 meter. So the vertical displacement is y, which is 1000 meter, and we are supposed to determine the range first. So we are going to consider range as s. Now we are treating this numerical. So using kinematical equation in vertical motion, s equals to ut plus half at square, and substituting s equals to 1000 over there, we got the value of time, and the time comes as 14.3 seconds. When I multiply time by the only formula which is applicable in uniform velocity motion, so when v is equals to s by t is the only formula in horizontal motion. When I multiply that time with velocity, I get the range. So the range is velocity into time, which is 30 into 14.3. 30 is the velocity and 14.3 is the time. So we got range as 429 meter. Next we are supposed to determine the final velocity and direction of the bomb. So the bomb is hitting the particle at point B. So we are supposed to determine the final velocity. So if we want to find the final velocity, initially the particle was released in horizontal direction. So the initial velocity was 0 and it is going to accelerate because of acceleration due to gravity, and it is going to attain a velocity of 140.1 meter per second. This is the vertical velocity. This 140.1 meter per second is the vertical velocity, whereas the horizontal velocity is 30 meter per second. So using the formula of resultant, we will be getting the angle theta over here. Taking tan inverse of summation fx by summation fy, will get theta is equal to 12.1 degree. So we got theta as 12.1 degree. Similarly, we are going to take square root of square and we are going to find the final velocity, which is 143.3 meter per second. So the final velocity is 143.3 meter per second and the angle by which it hits the target is 12.1 degree. Now let's read the next question. It is asked to find the least initial velocity which a projectile may have so that it may clear a wall 3.6 meter high and 4.8 meter distant and strike the horizontal plane through the foots of the wall at a distance 3.6 meter beyond the wall. The point of projection is at the same level as the foot of the wall. So let's understand that with the help of this diagram. So a particle is projected. From point O and it has to clear the wall at point A and it will further hit the ground at point C. Is that okay, my dear friend? It is said that the height of the wall is 3.6 meter. So we are supposed to throw the ball in such a manner so that it crosses the wall. So the maximum height in this range, in this question, will be 3.6 meter, and the particle was thrown from point A and it hits the ground at point C, and it is said that they are at the same level. So the range of this projectile is 4.8 plus 3.6 and that becomes 8.4. Is that okay, my dear friend? So now we are supposed to do the analysis of this question. So as this is on the same level, we can use the equations which we have derived in this video lecture, such as the formula of range can be used, formula of maximum height can be used, the equation of path can be used, equation of a trajectory can be used. So let's use the equation of trajectory and let's substitute that at point A. So when I do the analysis at point A, the y is 3.6, y is 3.6 and x is 4.8. So y is equals to x tan alpha minus g into x square divided by 2u square cos square alpha. So here we have got a equation in the terms of u and alpha. We have got a equation in the terms of u and alpha. So we are supposed to have another equation in the terms of u and alpha. So I take the formula of range. The formula of range, so the range is 3.6 plus 4.8, that becomes 8.4. 8.4 is equal to u square 2 sin alpha cos alpha upon g. So once we substitute this and we take that as in the form of u square, I use this equation and I take this in the form of u square and I substitute u, I got u square is equals to 4.2 g upon sin alpha cos alpha. I substituted this equation in the previous y is equals to x tan alpha wala equation. So I substitute this equation, I substitute this value of u square in the previous equation and I do the analysis and I get 3.6 is equals to 2.06 tan alpha. So with the help of that I get alpha is equals to 60.2 degree. Here there is a complete step by step information of how we found the alpha, and with the help of alpha we are going to find the final velocity. So this is the velocity by which the particle was projected at an angle of 60.2 degree and it have cleared the wall at 3.6 meter. Now let's do the last question of this video lecture. A projectile is fired from the edge of a 150 meter high cliff with an initial velocity of 180 meter per second at an angle of elevation of 30 degree with the horizontal. Neglecting air resistance, we are supposed to find the greatest elevation above the ground and the horizontal distance from the gun to the point where the projectile strikes the ground. So here there is a very good diagram for this question. So the particle was thrown from a height of 150 meter. The particle was thrown from a height of 150 meter, let us say point O, at an velocity of 180 meter per second at an angle of 30 degree, and it is going to fall on the ground at point A. We are supposed to find out the maximum height, greatest elevation. So we are supposed to find out the greatest elevation. So this is the greatest elevation with respect to the ground, and that can be written as 150 plus h. I consider this as a plane motion, and for this much part we can apply the formula of maximum height. So if I add 150 plus h, I will get the greatest elevation. And next is to find out the horizontal distance from the gun to the point where the projectile strikes the ground. So that is the range, and that can be found with the help of horizontal and vertical treatment. So first of all we are going to consider that from motion O to P at the same level, and we are going to use the formula of maximum height. So the greatest elevation above the ground reached by the projectile needs to be found. So what we have already learned that it is 150 plus h, and the formula of h is u square sin square alpha upon 2g. So I substituted u as 180 meter per second and I substituted alpha as 30 degree and I got the value of h. I added that h with 150 and I got the maximum vertical height as 563.3 meter. Is that okay? Now next we are supposed to determine the range. To determine the range, we are supposed to consider the whole motion O to A. So we are considering the whole motion O to A. So there is a vertical motion and horizontal motion, and the initial velocity was 180 meter per second at an angle of 30 degree. So the horizontal component of the velocity becomes 180 cos 30, that becomes 27.76, and for the whole horizontal motion it is constant. If we find the total time of flight, and I multiply the time of flight with this velocity, I will get the range. So the initial vertical velocity was 180 sin 30, that it becomes 90 meter per second. It is under the influence of acceleration due to gravity, as the particle is projected upward and the acceleration due to gravity is downward. So it is taken as minus 9.81, and we are supposed to determine the range, and when the particle is thrown it is falling on the ground and the displacement is 150 meter. So taking displacement as 150 meter and using the kinematical equation s equals to ut plus half at square, we get the formula, we get the value of time which is 19.88 second. I multiply that 19.88 second with 27.76 and I got the total distance traveled by the particle, that is the horizontal range, that is 3102 meter. So with this I complete this lecture on projectile motion. I hope this lecture is definitely helping you and I wish you all the best. I thank all the students for being with me. Thank you my dear friends. Thank you.